There we go. Hey, Caleb.
Hello.
How are you doing?
Doing all right. Doing all right. Just getting ready for the review for today.
Are you at home or are you in a library or something?
I am at home.
Oh, okay. I just could hear people in the background.
Yeah, that's my grandparents. They're talking on the phone.
Ah.
Yeah. Yeah, usually my microphone is trouble, so you can hear them.
Hey, James. How are you?
Real well, thank you.
Good.
Are we going to be finishing the chapter 1 review first, or
Yes.
it's actually from chapter 1, I think, right?
Yes, from the
Section
first
1. Yeah.
half.
Yeah. Okay.
Yeah, I still had a few left to go on that, so we'll go over those.
How many questions will be on the final? Have you decided, or have you made it yet?
I haven't decided. I haven't made it yet.
Cool.
Oh, that's wonderful. We have to have that extra set of fear and wonder that how many
It'll be fine. Why will this not erase? This is so weird. Huh. Trying to get something to erase off the screen and it just doesn't want to erase. Everything else is erasing. Oh. Beats me. That was really weird. Well, share screen. And it's this one right here. So weird. Hmm. That's really weird. Well, I'm going to go ahead and start. And this is that first review I had made up for you all. It said review chapter 1 on it. There was 25 questions and we had gotten stopped at number 18. And I was trying to erase, but for some reason it wouldn't let me. I don't know what's going on. But it does say right here, solve the equation in the complex number system. And so we're on number 18 here. And it's already set equal to 0, but I cannot factor that. There's only 2 factors of 7, 1 and 7, and that adds up to 8. And right here, I actually have a 1. So this sucker is not factorable. So I'm going to have to use the quadratic formula. Woohoo! Let's see. So A is a 1. And the B is a 1. And I don't know why my I know there was a way to lock this screen, but I can't figure it out right now. All right, and then C is 7. And then the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I am going to remove the letters and substitute in parentheses for them all so that I can stick in the numerical values. So let's see, B was a 1, so I need a 1 here and a 1 there. And A was a 1, so I need a 1 here and a 1 there. And C was a 7. Okay. So now, sorry, my phone was ringing. I was like, what is that noise? It's vibrating. So it's going to be negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 1 times 7 is 28. All over 2 times 1 is 2. And then when I take 1 minus the square root, or 1 minus 28, I get a negative square root of a 27. Now, I can simplify my square root of 27. This guy right here, I'm going to break him down. He is going to break down to be the square root of negative 9 times the square root of 3. So that I get negative 1 plus or minus. And when you take the square root of negative 9, that is a 3i. But you still have this. You still have the square root of 3 all over a 2. And if they want it in the a plus bi form, let's see, do I have room for this? Whoops. Not much. If they want it in the a plus bi form, you have to split it to be, you give the negative 1 his own 2, and then you give the 3 square roots of 3 its own 2, and then the I would pop out on the side like that. And that's my answer. It's not pretty, but that's in a plus bi form. Well, that was fun. quadratic formula. Okay, and then when I get to number 19, this is an equation, so we're solving for x, but it has a square root in it, so I have to get rid of the square root. And I'm trying to remember how the heck I can lock this stupid thing so it will stop. Oh wait, there it is, pin it. There we go, pin it to the taskbar. Okay. So everybody got this so I can move ahead? Anybody need me to hold off? I guess I can work with it. You have to get your radical by itself first, and it is. So I'm going to take the left side where the radical is and square it. But what you do to one side, you got to do to the other. Now the square will cancel out the square root, and that'll just leave me with the x plus 5. And then 5 squared is 25. And then I'm just gonna subtract 5 from both sides so that that cancels. And I get x on the left and it equals a 20 on the right. And if you check it, which you should, this would be the square root of 20 plus 5, which is the square root of 25, which is 5, which checks with that 5 on the other side. So this 20 is the right answer. And then 20 is just like 19. It's another radical. You have to get the radical by itself, which it already is. So I'm going to square the left side. Now the trick on this one is you have to square the entire right side, the entire x plus 3. You can't square the x and square the 3 separately. You actually have to take an x plus 3 times another x plus 3. Now on the left side, the square and the square root, they just cancel each other out. So you're just left with the 16x minus 16. That's easy. On the right, however, I will have to go through the FOIL process. So first times first is x squared. Outside is 3x, inside is 3x, and last times last is 9. And then I can combine like terms because the 3x and the 3x are like terms. So it's going to be x squared plus 6x plus 9. Now, in the process of doing all that, an x squared shows up, which makes this quadratic. So now I have to shift gears and say, all right, to solve a quadratic, I have to set it equal to 0. So I'm going to subtract 16x on both sides. And at the same time, I'm going to add 16 on both sides, so that the 16x's cancel and the 16 cancels, and that's just 0 on the left. And then on the right, I'll have x squared, positive 6 and negative 16. It's a negative 10x. And 9 and 16 is 25. And then, of course, once it's set equal to 0, you're either going to factor or use the quadratic formula. And this one actually factors. For the x squared, it's x and x. And then I need 2 factors of 25 that add up to negative 10. So that'd be negative 5 and a negative 5. Negative 5 times negative 5 is positive 25. But negative 5x and negative 5x for outsides and insides adds up to negative 10x, which is my middle term. These are identical twins, which means I really only have one answer, and that is x is 5, because this would also be x is 5, but you're only going to list it once. And if I were to check it, you would have to plug it in where this x is and that x on both sides. So this would be the square root of 16 times 5 minus 16, and the big question is, does that equal 5 plus 3? Well, 5 plus 3 is 8. Let's see, 15 or 5 times 16 16 is 80. And 80 minus 16 is 64. And the square root of 64 is 8. 8 equals 8. It checks. So that means 5 is the right answer. So any questions on radical equations? Oh wait, there's one more. Oh yeah, this one. Okay, this one has not one, but 2 radicals in it. And you have to get the radical alone before you can square it off. So first you're going to have to isolate one of them, square both sides. Left side will be easy, right side will be a complete disaster mess. Then you'll have to isolate the radical that's on that side and go from there. So I am going to, since I have a minus, square root of x minus 2, I'm going to add square root of x minus 2 to both sides. Cancels out there. I'm just going to be left with the square root of the 2x plus 5 on the left side of the equal sign. And on the right side, I'll just have 3 plus the square root of an x minus 2. And now I'm going to get rid of the x squared, the square root of the square root sign on top of the 2x plus 5. That's what I'm going after next. So I'm going to square this. The square and the square root cancel each other out, and that just leaves you with the 2x plus 5. However, you're going to have to take the entire left side and square it, which means everything inside the parentheses times itself. You have to take a 3 plus a square root of an x minus 2 times another 3 plus the square root of an x minus 2. Yep, we got to FOIL that mess. Okay, so we are going to start with first times first. First times first gives me the first term here. 3 times 3 is 9. Then I'm going to multiply my outsides, which would be this 3 times that square root of an x minus 2. That'll be my outsides. So that's going to be plus 3 times the square root of an x minus 2. That's this. Then I'm going to go to my insides. My insides would be this guy times that guy. So my I is going to go right here. And that's another plus 3 square roots of an x minus 2. And then I'm going to do last times last. Now, when you take last times last, I'm going to actually do this up here. You're taking a square root of an x minus 2 times another square root of an x minus 2. Which means what you're really doing is the square root of an x minus 2 squared, which means you're just going to be left with the x minus 2. And it was a positive times a positive, so there'll be a plus sign right here. Whew, that was fun. now I'm going to combine like terms. So, let's see, how about orange? Give me some orange. I can combine the 9 at this end and the -2 at that end. 9 and -2 would be 7. And then I've got 3 square roots of an x minus 2 plus 3 more square roots of an x minus 2. So those connect, and that becomes 6 square roots of an x minus 2. And then the only thing I didn't underline was this x, and he's just by himself. He is not under a radical. So at this point, what I have is 2x plus 5 is equal to a 7 plus 6 square roots of an x minus 2 plus x. And I need to now isolate the square root of an x minus 2. So I am going to subtract the 7 from both sides and subtract the x from both sides. That term cancels, that term cancels. I'm left with x minus 2 equals 6 times a square root of an x minus 2. Now, I could divide off that 6, but I'm going to create a fraction on the other side. So it's actually easier just to leave the 6 there. You just have to be careful when you're doing the next step. And my next step is going to be, I'm going to move over here to the left. I'm going to take the x minus 2 on the left and the 6 times the square root of x minus 2 on the right. And I am going to square both sides. So that means on the left, I'm going to have an x minus 2 times another x minus 2. And then on the right, I'm going to have 6 times the square root of an x minus 2 times a 6 times the square root of an x minus 2. Now, the left side, those are 2 binomials because there's 2 terms, x and minus 2. But on the right side, those are not binomials. That is 4 things multiplied together. Let's see, I have a 6. It's too big. I have a 6 times a square root of x minus 2 times a 6 times a square root of an x minus 2. This is all multiplication, and so I can multiply those in any order that I want. On the left side, I'm going to have to FOIL this out right here. I'm going to FOIL this. So first times first is x squared. I'll have a minus 2x on the outside and a minus 2x on the inside. That's a minus 4x altogether. And then last times last, so negative 2 times a negative 2 would be a plus 4. That's the left side. I FOILed that. On the right side, what I'm actually going to do is multiply the 6 times the 6, because those numbers are not underneath a radical. I can take 6 times 6, and that is going to give me 36. And then I'm going to take the square root of an x minus 2 times another square root of an x minus 2, which is what I did. Oh, crap. Sorry. It jumped on me. I was just trying to slide a little bit. Which is what I did up here in this highlighted blue. See it? Square root of x minus 2 times the square root of an x minus 2 is the square root of an x minus 2 squared, which is just x minus 2. I'm doing that again. Guess I should have highlighted it in blue again, huh? Instead of pink, but that's all right. So the thing you have to be careful of is when you write down that x minus 2 right here, because the 36 is in front of it multiplied, you have to put this in parentheses because you're going to have to distribute. That's the tricky part. So, boy, this is a long ass problem. All right, x squared minus 4x plus 4 equals 36x minus 72. And then I'm going to set it equal to 0. So I'm going to subtract 36x from both sides. All right. And in the same breath, I'm going to add 72 to both sides. So I'm going to have x squared minus 40x plus 76 is equal to, those cancel, that's 0. Oh boy, and now I need 2 factors of 76 that add up to a negative 40. Well, it's not 1 in 76, 2 times 38. There we go. This is x and x. It's going to have to be a negative 2 and a negative 38. That adds up to the negative 40 in the middle, but multiplies to give me a positive 76. So my answers are 2 and 38. Those are my possible answers. And you should go back and check them. And with a calculator, it wouldn't take too long, but they actually both check. So they are both answers. But if you're doing Mymathlab and you typed in both answers and then it said, you know, it's wrong, more than likely one of your answers was right and the other one was wrong and you didn't check them. Because a lot of times in radicals, you have what they call extraneous roots, numbers that don't actually check. So that was fun. That's probably the hardest problem we have worked this semester because there was so much involved. I mean, you're using everything. You were dealing with a radical, you had to isolate it, you squared, you foiled, combining like terms, you had to set it equal, you had to do another radical. Then the x squared shows up, and you got to switch gears to the quadratic equation type stuff. What do I do there? You know, then factoring, good God. It has it all. It's like one-stop shopping for math. All right, next. This one says, express the graph shown using interval notation. Also express it as an inequality involving x, and they're telling you to use x. All right, well, when I'm looking at this thing, I've got a bracket at this end and a parenthesis at that end. So that's what my interval is going to look like with a comma in between. And then when I look at my numbers, I've got a negative 2 here. That's what's going to go in this spot. And at the other end, you have a 5, and that's what's going to go in this spot. So it's bracket, negative 2, comma, 5, parenthesis. So that's interval notation. And then they want to express it as an inequality involving x. So when you go to do this part, it's going to be an in-betweeny because x can be in between the negative 2 and the 5. And because the negative 2 has a bracket, I need less than or equal to. 5 has a parenthesis, so you just need a less than. And that is that answer. All right, and then the next one gives it to you as an inequality, wants you to write it in interval notation and also express it on a number line. I'm going to do the number line first because it just, you know, is easier. So somewhere I need a 1. Let's just make this the 1, which means this would be 0 and this would be 2. And then we've got x is less than 1. So I go to the 1. I put a parenthesis on it because it's not an equal to, and then draw my arrow going in a less than direction. And then as an interval, I can see that that arrow is pointing to negative infinity, right? So it's starting way down here at negative infinity and then comes up to the 1, but doesn't include it. So that's what it looks like in interval notation. And then this one says, solve the inequality, express your answer using interval notation, and also graphing it. I didn't say that in the directions, but there's a number line there. They want me to graph it. All right. Let's start by getting rid of them there parentheses, which means I'm going to distribute the -3. -3 times 1 is a -3. -3 times -x is a +3x. That's where the parentheses end, so that's where the distributing ends. I can combine the 5 and the -3, that would be 2. And then I'm gonna subtract 2 from both sides, cancels that. I get 3x is less than or equal to -21. And then I'm going to divide both sides by 3. I am not dividing by a negative. I'm dividing by a positive, so I do not reverse my sign. X is going to be less than or equal to a -7. So that's my inequality. Then they wanted an interval notation. So an interval notation would be, since it's less than or equal to -7, and I like to graph it first. Where's -7? -7 is right there. So I would need, it's an equal to, so you need a bracket, and then highlighting in the less than direction, which means my interval starts at -infinity, way to the left, comes up to -7 and stops and includes it. And that's my interval notation, and there's my graph. And then the last problem was an in-betweeny, and I'm gonna recopy it down here. You can see that there's 3 parts to this. You've got the 18 at the left end, the 28 at the right end, and the 5x minus 2 in the middle. And the less than or equal to's, you know, separate those things. So the first thing you're gonna do is you're gonna add 2 to cancel the 2 from the middle. But you have to keep it balanced at both ends at the same time. So all 3 sections are going to add 2. 18 and 2 is 20. It's like my pen is on a 5-second delay. And then 28 plus 2 is 30. And then I'm going to divide off the 5 so that it cancels in the middle, leaving me with just x. But I have to divide 5 on the left end and divide 5 on the right end. So that 20 divided by 5 is a 4. There's the x in the middle. And 30 divided by 5 is a 6. So here's my inequality answer. As an interval, I would need brackets at both ends because of the fact that I have an equal to on this right? You've got an equal to here and an equal to there. That gives you the brackets. And then I just need to go from 4 to 6. And so in this number line, let's say this is 0, 1, 2, 3, 4, 5, 6. So I would need a bracket here and a bracket there and highlight everything in between. And that's the end of that. Questions on the rest of that one? Okay.
What section is the first half of the review in or with on your Zoom tube? Do you remember 1.8 or something like that? You know what I'm talking about? When we did the first half, we started and then again finished, and we just finished today.
What you mean? What recording?
Yeah, exactly. Is it 1.8 or I can't remember when we started it. And we
you know
didn't
what?
finish.
I can't remember either.
I think it was right after we started the next,
Let me see. Hang on. Let me go over to our class and go to syllabus because it's on the calendar.
I hope that's not a weird question.
Review day. The calendar says 9/16, but I think we actually did it 9/21.
Okay, thank you.
Because I was behind, remember, in the beginning because we missed that
Yeah,
first day.
and we just now finished. I just wanted to review the first half
Yeah.
again.
And I can't remember if I had caught up to it or not at that point. So it's either on September 16th or September 21st. There is no 1.8. We did 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. And then we jumped to chapter 3. 3, 1, 3, 2,
Okay.
3, 3, 3, 4, 3, 5, and
Cool beans.
4.3.
Thank you.
You're welcome. Okay, so now that's that one, and this is chapter 3 stuff, and I need to share this screen. There it is. Okay, now this one, the first one I created, and this one came from one of the other math instructors. So I just found out today, I'm gonna create my exam on Mymathlab. And what I'm gonna do is I'm gonna open it we start class at 4, right? I'm gonna open it at 4 and give you 2 hours because normally we meet for an hour and 15 minutes. But I'm gonna give you 2 hours from 4 to 6 to work on it. It'll probably be, I don't know, 25, no more than 30 questions. And that might even be pushing it. So I'm thinking about 25 questions. And what I'm gonna have you do, and don't worry, I'll put all this in an announcement, is you have to insert your answers into Mymathlab, all right? And then Mymathlab will count it right or wrong. Well, even if you're off by a hair, it's going to count it wrong, if you put a comma in the wrong spot. So I want you to get some blank paper and work out your problems as you're doing them. Show me the work, number them so I know what number it is. I will not play Where's Waldo, seek and find. I'm not going on a seek and find mission on your blank paper. And show me all your work. And then when you're done, I want you to take a picture with your phone of your work and then just email me the pictures. That way, any problems that you do get wrong, I can go look at your work. And if you're off by a comma, I can, adjust the grade accordingly. Does that sound fair? It'll be open book and open notes, but it will be timed. So you only have about 2 hours to get through it.
So I was about to ask this as I asked this. It is open book and open notes?
Yep. It's going to have to be.
Okay. Thank you.
There is absolutely no way I can proctor this exam with I have a Microsoft laptop pro thing, whatever you call it. It's not very big. There's no way, even if you all got on Zoom at the same time with me watching you, I wouldn't be able to tell. I can't see nothing on this thing. It's so small. So it's just going to have to be open book and open notes, but you're going to be timed. So you got 2 hours and that's it. Okay.
All right, and is each of the questions, like in the Mymathlab, a final check first try, right? There's no 2 or 3 tries like the Mymathlab homework.
Right. You get one chance. Yep.
All right, thank you.
One chance. I will set it so that if it's got multiple parts, like there's parts A, B, and C, like find the domain, find the range, or whatever, it'll lock in your correct answer. So it'll know that. Although I guess you won't know till the end anyway, so it doesn't really matter, does it? No, it doesn't. So, but yeah,
will there
one
be
shot.
hopefully maybe a bonus in case we really screw up one place? Maybe we do better than another.
That's what the blank paper is for, showing me your work so I can look at it. Because you know, some of these equations, it takes a lot of steps. So like that one I just worked, which don't worry, I'm not going to put one of those on the test. No way in hell.
I wouldn't mind that. Like, to me, those are some of the easiest problems, just because I hate graphs.
I mean, I'm definitely going to put a radical one on there, but it won't be the one with the 2 radicals that just took me, 10 minutes to go over. And I can't guarantee it won't be on your final, but on the midterm, it won't be.
Crazy. So, thank you.
Okay. So let's see how far I can get with this. And let's see, determine whether the relation represents a function. And if it is a function, state the domain and the range. I'm looking at, they gave me a drawing on this one, and I can see that these are your X's, that's your domain, right? Those are your inputs. And where the arrows are pointing is your outputs. So I just label them X and Y instead of input and output. X is domain, range is Y. However, when I'm looking at this, I can see that Carl here maps to 2 different things in my range, which means this is not a function. Remember, every X can only go to 1 and only 1 Y. But you can have I could have Alice, Brad, and Carl all going to, let's say, cat. But they can only go to either just cat, just snake, or just dog. They can all go to the same one, but each individual can only go to one. The next one, is this a function or not? X equals Y squared. This is not a function. And if you remember, I told you about graphing it. Here's my X and Y axis. Because I have, there we go. Because I have X to the first power, this graph is only going to cross the X axis once. However, because my Y is to the second power, this thing is somehow going to cross the Y axis and then turn around somehow and cross the Y axis the second time. Okay, so that didn't draw very well. It's got to be up higher than that. Sorry. It's got to go something like, it's crossing the X, it comes up and it crosses the Y, curves and goes like that. There we go. So it's going to cross the Y axis twice and the X axis once. It's going to have some kind of a, it's actually a sideways parabola now that I think about it. So that does not pass the vertical line test. So that's a B. It's not a function. This was C. Okay, 3 just wants the domain. If it's a polynomial, like if that had just, if if you didn't have this here at all, if it was just g of x equals 2x, then the domain would be all real numbers, negative infinity to positive infinity, any kind of a polynomial. But if you have a fraction with an x in the denominator, or if you have an x under a radical, then there's some rules you got to follow. In fraction land, there's basically one rule about denominators: they can't be 0. So my x squared minus 36 is not allowed to be 0. And if I factor that, I get x plus 6 and x minus 6, which means this x right here is not allowed to be a negative 6 because it would cause that to be 0. And this x is not allowed to be a positive 6 because it would cause that to be 0. So my answer is B. And they put this in that set builder notation. It's the set of all x such that x cannot be a negative 6 or a positive 6. Now, had they asked me to put it in interval notation, then I would have said, okay, it goes from negative infinity up to the negative 6, but doesn't include it. And then you'd put a union symbol. And then you'd say, okay, and then it goes from the negative 6 to the 6. And then you'd union that. Sorry, I put a second negative there. And then you'd pick up on the other side of 6 and go all the way to infinity. And that'd be the same answer. So on that one, set builder notation looks a lot better. It just can't be 6 or negative 6. And then on number 4, this one has the radical in it. A radical, and it's in the denominator. So first of all, the square root of x minus 5 has to be, actually, normally I say greater than or equal to 0 because you can take the square root of 0, but that would be 0. And your denominator can't be 0 either. So I'm just going to say it has to be greater than 0. And then I'd square both sides. And that leaves me with x minus 5 is greater than 0. And then I would just add 5 to both sides to figure out what x has to be. And x has to be greater than 5. Because if you put 5 right here where that x is, 5 minus 5 would be 0, and the square root of 0 would be 0, but then you'd have a 0 in the denominator, and you know, things implode when you put zeros in denominators. So it cannot be an equal to, it's got to be greater than. And that would be choice C, right there. Okay, then we're going to do that composite function stuff again. Oh boy. Okay, for the given functions f and g, find the requested function and state its domain. The requested function in this problem is right here. Find f minus g, which just means you're going to take f of x minus g of x, okay? F of x minus g of x. F of x is this 9x minus 9. That's what goes here. And g of x is 4x minus 7. And I have to subtract. So you can either distribute or you can do it mentally. I like to sometimes do this mentally. So I'm like, okay, I'm going to take this 9x minus this 4x. 9x minus 4x is going to give me a 5x. And then I'm going to take a negative 9 minus a negative 7. Okay. -9 minus -7 is -9 plus 7, which would be a -2. So that's what I get right there. So let's see. And these are both polynomials, so there would be no restrictions. Yeah. I don't know why they're saying over here they've got, they're saying this stuff and this stuff where it can't equal stuff. That only applies if you've got x's in denominators or x's under radicals, so it can't be either of those. And I got 5x minus 2, so it's A. A, all real numbers. And the next one, gotta love multiple guess. I might make your test multiple guess easier. Sorry, multiple choice also. That way, that might be better. If I can do that. Ooh, can I do that in Mymathlab? I don't think I can, unless it's an option. Because that would save me some time with typos. Okay. F of x equals the square root of x. G of x is 4x minus 1. They want you to find f over g. So you're actually going to be taking f of x and putting it over g of x. And of course, f of x is the square root of x. So that's what's going to go here. And g of x is a 4x minus 1. So that's going to be my denominator. Now, because I'm dealing with something in the denominator and something under the radical in the numerator, I have to think about both of them. For the blue, whatever x is, the square root of x has to be greater than or equal to 0. Because I could have a 0 for x up there. The square root of 0 is still 0, and 0 divided by anything is 0. Okay. For my denominator, the 4x minus 1, since that's what's in the denominator, that cannot equal a 0. And to solve that, I'd add 1 to both sides and divide by 4. So x is not allowed to be a 1/4, and x also has to be greater than or equal to 0, because if you squared both sides here, sorry, I never finished this one, then I'd have x is greater than or equal to 0. So it's C, because here's the x is not allowed to be 1/4. And here is the x has to be greater than or equal to 0. And here is the actual function, the square root of x over 4x minus 1. So it's C. Okay, and this is the function stuff we just went over recently. When I'm looking at my picture, I see the graph of the swoosh. A swoosh, that's what I affectionately refer to it as. And that was the basic function of y is equal to the square root of x. However, and actually that would have been right here. It would have been like that. Our graph got shifted to the right to here. So when it shifts right or left, that is under the radical. So I'm actually going to have to extend my radical. This is going to be the square root of x. And then because we went 1, yeah, let me look at the numbers. There's a 5 right there. Here's a 5. So 1, 2, 3, 4, 5. So it went 1 to the right, which means this has to be a -1. So my answer is A. Okay, determine whether the graph is that of a function. Yes, it is, because it passes the vertical line test. Yes, it's a function. No matter where I would draw a vertical line, it only crosses it once. Only crosses it once, so it's a function. And then they want to know the domain. Okay, the domain is how this graph spreads across the x-axis. It starts here, it goes up, it goes down, it goes up, and it ends right there. So it starts at -1/2 and -1/2, wow. It starts at -pi and it ends at pi. Phew, I don't know why I said that. All right, so -pi to +pi.
Wouldn't those be brackets because they're filled in?
Oh, yes, it would be. Thank you. You're right. There's solid dots. Solid dot. Solid dot. Okay, so that's my domain. Now, the range is how it's spread from top to bottom or bottom to top. And so when I'm looking at this, my lowest point is right here. And my highest point is right there. So my range goes from -1 to +1. And these would be like solid dots here also. My lowest point, those are solid dots. So I would need brackets there also. So my range. Okay, then we want the x-intercepts. There are actually 3 of them. My x-intercepts are here and here and here. Sometimes Mymathlab would say just separate them with a comma. So if it said that, I'd just say it crosses it at -pi, at 0, and +pi. But if they wanted them as ordered pairs, it would be -pi 0, comma, 0, 0, comma, and pi 0. So whatever Mymathlab tells you to do. And then they want the y-intercept. Well, the y-intercept is the same as the x-intercept right here. This is my y. That's the only place it crosses the y-axis, and that is the origin. So you're either just going to say the y-intercept is at 0 or 0, 0 if they want an ordered pair. Okay, and then it wants to know symmetry. Is it with respect to the x-axis, the y-axis, the origin, or none of these? I always start with the y-axis because that's like the heart, you know, where you fold it this way. And if I were to fold, if I were to take this graph and fold it along this line right here, this guy would come over and be like this. It's not matching up. So it's definitely not symmetric around the y-axis. For the x-axis, I'd be taking this graph and folding it down, and then this would come down like that. And this would come up like that. When you flip it, it's not going to be symmetric. Oh, I forgot to do the other one too. Sorry. This one goes here. It has to match, and it's not going to match. Well, I guess if you're folding it, it wouldn't match either way. Nope. So that one's out. And then the last one is the origin, which is a double fold. I guess I didn't mean to do that right there, sorry. The double fold, need another color. Okay, so the original graph was this. If you fold it down, this goes down here, and you fold it first along the x-axis, and then if you fold it again along the y-axis, it will end up right on top of this over here. I don't know if you can see that, but that's symmetric around the origin. I have to do a double fold. The picture didn't come out. They all look the same to me. Oh, I know what I forgot to do. I forgot to draw this line here. Yeah. First time I was folding it along the y-axis. Second time I was folding it along the x-axis. And the third time I folded it along the x and then along the y. I did a double fold. It works much better if you have a piece of paper, you know. Oh gosh, I'm still not done. On which intervals is or are the function increasing? On which are they decreasing? Okay, this is when you definitely only use parentheses. And okay, if we're looking for where it's increasing, it is increasing here and here. So it's going between here and here, and then here and here. This is where it's increasing. So from left to right on this, my intervals are from the first one. Remember, on increasing and decreasing, you look off the x-axis. So it goes from negative infinity on the x up to negative pi over 2, comma. And then the other yellow is from pi over 2 to pi. I did a horrible job of drawing these. It goes from here to, come on, pen, to here. And then from here to here. Just trying to highlight that in yellow, which I did a horrible job. It's in between here. And then when we're doing decreasing, where's the function decreasing? It decreases in between here. So it's actually this entire area from left to right. So for decreasing, it's just one interval, which starts at negative pi over 2 and goes to pi over 2. And if you look at your increasing intervals, right here, you've got negative pi over 2 and pi over 2. So the blue, this is actually in between those two because it goes yellow, blue, yellow. So yellow, blue, yellow. Did that make any sense?
Yeah.
Okay. I miss being able to see your all's faces because, you know, when I look out and somebody's got this like really perplexed look on their face, I know I did something crazy. All right, answer the question. Given the function f of x equals blah, 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 list the x-intercepts, if any, of the graph. An x-intercept is where it crosses the x-axis. And that is when the y coordinate is 0. So we are going to have to put a 0 right here. Remember, f of x is really your y coordinate, so we put a 0 there. And then set that equal to x squared plus 8 over an x minus 7. And you have to solve this for x. And I have a fraction, so the first thing I'm going to do is multiply both sides by an x minus 7 so that it'll cross cancel out on the right. But x minus 7 times 0 is just 0. And on the other side, I've just got the x squared plus 8. And then I'm gonna subtract the 8 from both sides. Cancels that out. Come over here, I'm running out of room. 0 minus 8 is a negative 8, and that's equal to x squared. And then right here, if you are like, hey, I gotta square root the x squared to get an x, but then look what happens. Sure, you get an x over here, but this is actually imaginary. And you can't graph imaginary points. So my answer is D. There are none. That's it. There are none. And it definitely wouldn't be C because 7, 0, if you put 7 in there and you'd get 0 for the denominator, and you can't divide by 0. So that was all kinds of wrong. Okay. Is f of 3 positive or negative? F of 3. You are looking for the point whose x coordinate is 3. So I'm going to go to the x-axis at 3. This would be here, wouldn't it? Isn't this 3? So it would be this point right here. And since that point is in quadrant number 4, that's where all of my y coordinates are negative. Be this point right here because his x coordinate is 3. This is 1, 2, 3, right? But his y coordinate is negative 2. Negative. Because they're asking you, is f of 3? F of x means the y coordinate, but they specifically said f of 3. So I'm looking for the y coordinate of the point with an x coordinate of 3. Given the function f of x equals blah, 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 if x equals negative 1, what is f of x? And what point is on the graph of f? All right, this is just a plug-in and chugging. You are going to take, if x is equal to negative 1, you're simply going to put that negative 1 where this x is and where this x is, and calculate what f of x is equal to. So I'm actually calculating f of the negative 1. Negative 1. Switch to a smaller pen. I don't know. So it's x squared minus 3 over x minus 2. And I'm going to stick my negative 1s in right there. So negative 1 squared is 1. And 1 minus 3 is -2. And then -1 minus 2 is really -1 plus a -2, which is a -3. But a negative divided by a negative makes that a positive 2/3. And keep in mind, that is your y coordinate. So my ordered pair, the 2/3 would go right here. And the x was -1. So I am looking for the point that has this as f of x. Well, this one has that, and this one has that. That one's out, and that one's out. And then I want this ordered pair, which -1 2/3, it's this one right here. So my answer is C. Okay, given the function f of x equals, list the y-intercept. All right, the y-intercept is when x is 0. So I am going to plug 0 where x is here, and also x is there. And won't you just be left with the 4/9? You'd have 0 squared plus 4 over 0 plus 9. That's just going to be 4 over 9. So it's 0 4/9. It is choice B. B, 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 B. Match the function with the graph that best describes the situation. The x-axis represents time. The amount of rainfall as a function of time if the rain fell softly but constantly. Softly but constantly. Okay, well, constantly to me is more of a horizontal line. However, this has too much of a sharp uphill and then constant. And then this looks like hard and then soft. It's constantly, but softly at the same time. This one is going up, 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 and you can see it's curving. It's going to shoot up, which means it's going to rain harder and harder and harder as time goes on. So the only one that really makes sense is this one, because it's kind of a slow increase. Very slow. And also my answer key says B, so, you know. That makes sense to me. Softly but constantly. The graph of the function is given. Decide whether it is even, odd, or neither. This is an x cubed function. This is the basic function of y equals x cubed. Okay, I gotta go back to the thicker one. It's too light. And what you do is you plug in place of your x, a negative x, and see what the result is. Well, negative x cubed means negative x times negative x times negative x. And that's really -1 times -1 times -1, which is -1, and x times x is x cubed. So I went from an x cubed to a negative of an x cubed, and that is the definition for odd. If you plugged in and x cubed became x cubed, it stayed x cubed, that'd be even. But if you get the opposite of your original, then it's odd. And then if you get something that's totally whacked out, then it's a neither. And then this one says determine algebraically, which is basically what I just did. This one, 15 should be neither. Yep, it's a C. When I take the f of x equals the square root of x, and I replace the x with a negative x, this ends up being undefined. You can't take the square root of a negative x. So you don't get the original function and you don't get the negative of the original function. So this is a neither. Oh, that was weird. Why did that happen? And now it won't erase. Something is weird on my computer today. Another one. Okay, these are all just even and odd questions. I'm hoping that makes sense. You just plug in the negative of the x and see what happens. I don't know why I've got so many of these, but I'm running out of time. So let's see. This graph is the square root function. That would be, hopefully got your notes and you got all those things written down. So a question like that would be easy. Find the numbers at which, okay. Local minimum and local maximum. There's actually, let's see. Wherever it changes from increasing to decreasing, right around that point, that is a local maxima. So I've got one there and I've got one right here. Wherever it changes from decreasing to then increasing, that's a local minima. So I've got two of them here and here. So they want to know what the maxima and minima are. Those are the y coordinates. And then it says at x is equal to whatever. So I'm looking at the greens. This one right here, you would say there is a local minima of negative 3.3 at x is negative 2.5. And then this other one over here, this one is my other, you'd say it's at negative 2.5, or it has a minima of negative 2.5 at x is equal to 5. And then the maximas, if I'm looking at this one, I would say it has a maxima at 5 at x is a negative 8. And then the other one, dark blue, this one, I would say the maxima is 3.9 and it occurs at x is 2.2. Is there more questions? No, that was it. Now this one says absolute maxima. Because this graph keeps going up and up and up and up and up and up and up, there is no absolute maxima. There's none on that. And then the absolute minimum would be the absolutely lowest point on the graph, and that would be this one right here. What is the absolute minima? The minima would be the y coordinate, so I would put 2 there. 2. And then the absolute maxima, that was none. And then the local minima is actually just the 0.12 again. This is an open circle, so you can't include that one. And then the local maxima, there are 2 local maximas at 6 and 5. 6 and 5. And it is now 5:15. So I have run out of time. Where's my thing? Here it is. Oh, stop sharing. I'm going to do the same thing I did last time. I'm going to dismiss you because obviously some of you might have another class, but I'm just going to keep recording this. So if you want to come back later and watch the rest of the problems and how I worked them out, there's not too many more to go, or you can hang around, whatever you want to do. And then I'm going to post an announcement later tonight. Somebody chat with me. Okay. about the test. And again, it's going to start right at 4 o'clock. It'll open up. So all you have to do is log into Mymathlab. You do not have to log into Zoom. Just log into Mymathlab and take your test. And then as soon as you're done, you'll take pictures of your scrap paper and email them to me. Okay? So if you need to leave, leave. If you want to stay, stay. I'm going to go back to sharing my screen and continue with this. Where was I? This one here. All right, so it's a piecewise function. It says circle the domains of each piece of the piecewise function. Circle the domains? Well, I'm going to highlight them instead. Circling the domains of each of the piecewise functions. This is this one's domain and this is that one's domain. Those are their domains. And then it says fill in the XY charts below. Is there something below? Oh, yeah, there they are. I'm going to have to shrink this down so I can see it all. There you go. Okay, for each piece, f of x for the top one. Let's see. This one. And the other domain is this one. Okay, so for the first one, which is f of x is negative x plus 2. You have to pick x's that are less than 0. So I would start with 0 and then go less. Negative 1, negative 2, negative 3. I guess they want me to fill in the whole table. Negative 4. And then just plug and chug. Negative 0 plus 2 is 2. Negative of negative 1 plus 2. It's negative of negative 1 plus 2 would be 1 plus 2, which would be a 3. Then negative of negative 2 would be 2 plus 2 is 4. Negative negative is 3 plus 2 is 5. It's just going up by 1 on each one. And then the other one, which will be the lovely pink one, it's this one here. It's like a 5-second delay. This one is the square root of x plus 3. And for this one, I have to pick, what was it? X is greater than or equal to 0. All right, well, since I'm plugging and chugging x, which is under a radical, I will stick, x will be 1 or 0. X is 0, x will be 1, and then I'd choose 4, and then I'd choose 9, and then I'd choose what, 16? All square rootable numbers. Because I have to take the square root of 0 plus 3, which is 3. The square root of 1 is 1 plus 3 is 4. The square root of 4 is 2 plus 3 is 5. The square root of 9 is 3 plus 3 is 6. I can see it's just going up by 1 each time. Okay, so that was fill in the charts below. I did that. Graph both pieces of the piecewise function showing where each piece begins and ends. Arrows if it continues to infinity, and whether the endpoints are included by showing closed or open dots. Okay, so the first one is 0 to x is 0, y is 2, negative 1, 3, negative 2, 4, negative 3, 5. I'm kind of out of room. This is the blue one. And okay, it said less than 0. So when I was at the x is 0, this here actually should have been an open circle right here. And then my graph is doing this, and it's keep going, so there's the arrow. And then the other one, the pink one, again, I cannot see my ordered pairs. We got 0 and 3, and this is greater than or equal to, so I would need a solid dot here. Over 1, up 4, over to 4, up to 5, over to 9, up to 6. This one's going like this, whoosh. It's a whoosh. So it's going like that, and it's definitely got arrows. Okay, and then the question is this function continuous? No. There is a gap at x is equal to 0. Remember, it's continuous as if you can trace it from left to right with your pencil and you don't have to pick up your pencil off the paper to jump to the next piece of the graph. I have to jump from here to here. There's a jump. So that's a big no. Suppose the x-intercepts of the graph y equals f of x are 2 and 3. What are the x-intercepts of f of x minus 6? Okay. Okay. Okay, right now, whatever my f of x function is, it's crossing at 2 and 3. I don't know what it looks like, but I know it crosses here and here. Okay, that was 2 and 4, April. Get it together, man. 2 and 3, all right? If you then, come on, green pen. If you then say f of x minus 6 and the minus 6 is in the parentheses, that means you are going to shift 6 units to the, remember if it says minus 6, you go to the right 6. So, in our color. So that means, I need to do it in green. This point here is going to go 1, 2, 3, 4, 5, 6. It's going to land right here. And this point's going to go 1, 2, 3, 4, 5, 6. It's going to land right there. And basically, you're just adding 6 to both of those. 2 plus 6 is 8, and 3 plus 6 is 9. So it would be choice, it's going to be choice C, because this is 8 and this is 9. Whew. 8 and 9. And then this says, suppose the point 2, 4 is on the graph of y equals f of x. Find a point in the graph with a given function. Y equals 3 times whatever f of x is. Remember that this is your x coordinate, and while we call it the y, it's also known as the f of x coordinate. So the x coordinate shouldn't change. It should still remain a 2. So it's either B or C. But the y coordinate is going to become 3 times that. It's going to be 3 times f of x. So 3 times 4 is 12. So that would be B. Okay. This is the same question. Now suppose the point 29, -5 is on the graph of y equals f of x. What is the translated point on graph of y equals 3 times f of x? It's still going to have an x coordinate of 29, but the y coordinate will be 3 times bigger. So that would be -15. 3 times -5 would be -15. And that's it. What's this next part say? Oh, okay. Suppose point A is at 2, 4 and is on the graph of y equals f of x. Graph and label point A on the graph that is given on the next page. All right, so point A is at 2, 4. We're going to go down to the next page and look at that. If I can get my page, 2, 4. 2, 4, over 2, up 4. It's going to be right there. All right, so I did that. Then it says, find point B, which is the reflection of the point 2, 4 across the x-axis. Across the x-axis. So if you were to fold this along the x-axis, this point, which is at 2, 4, would its mirror image would be at 2, -4. So 2, -4. Graph and label point B. Then it says find point C, which is in the reflection of 2, 4 about the y-axis. Okay, so if you were to fold this along the y-axis, fold it this way, then it's 2 to the right, it's going to be 2 to the left. It'll be right here. This is point C. So now that's -2, +4. Okay, and then point D, find point D, which is a reflection of 2x about the x-axis and then reflected about the y-axis, which really means around the origin. So you're doing a double flip. So first you're flipping it to the pink around the purplish color and then around the blue. And that's going to land me over here. There's point D, which is at -2, -4. Because first it would go here to here, and then it would flip again and go to there. Fold around the x-axis, then fold around the y-axis. And that's really a reflection around the origin. Okay, so that is -2, -4. And then find point E, which is in the reflection of 2, 4 about the x-axis, is shifted up 2 units and then shifted left 2 units. And I feel the need to graph this again over here. Okay, so 1, 2, 1, 2, 3, 4. My original point was in green. It was here. Okay, so we are going to, sorry, here was my blue. It's a reflection of 2, 4 about the x-axis. So that is the reflection about the x-axis. 1, 2, 3, 4. So a reflection of 2, 4 about the x-axis. That's going to take me to here. Then we are going to shift up 2 units. So up 1, 2 is going to take me to here. And then we are going to shift left 2 units. So left, or 7 units, sorry. 1, 2, 3, 4, 5, 6. So from the pink, I'm now going 1, 2, 3, 4, 5, 6, 7. I'm going to land right here, which is at 1, 2, 3, 4, 5. That is at x is -5 and y is -2. Yep, got it. All right, and 25. Got what, 3 more to go? Yep, 3 more to go. Okay, 25. If the y-intercept of y equals f of x is 7, what is the y-intercept of y equals f of x plus 2? Okay, so the y-intercept of y equals f of x is 7. So I know it's crossing right here at this point. But then we are going to take the f of x function and increase it by 2. So that means it's just the whole graph will shift up 2 units. So it's going to go up 1, 2 and land right here. So my new y-intercept would be 9. And then it says if the x-intercepts of f of x are -3 and +4, so 1, 2, 3, 2, 3, 4. So the x-intercepts are -3 and 4. And now we're going to do f of x plus 2. That means the plus 2 is added to the x on the inside of the parentheses. So we're going to shift 2 to the left. So this is going to go over 1, 2. So we're going to go 1, 2, land here, 1, 2, land here. And my new x-intercepts, 1, 2, 3, 4, 5. This one's -5 and this one's +2. -5 and 2. There you go. All right, graph the function by starting with the graph of the basic function. All right, our basic function. First, what is the basic function? For 7 over x, the basic function will be 1 over x. Actually, let me do this in red. Basic function is 1 over x. And basically what they did is multiplied that by 7, which means it's going to, because 7 over x is the same thing as 7 times 1 over x. So it's going to shoot up against the y-axis pretty quickly. And the original basic function of 1 over x is in quadrants 1 and 3, like that. So that automatically takes out A and B. And C and D, boy, these graphs really suck. Like somebody hand drew these pictures. 26, it's saying that it's D. Oh yeah, that's because it looks like that graph is touching the x-axis and the y-axis. Doesn't it look like this one's touching the axis? They're not supposed to touch the axis at all. So it's got to be this one. got to be D. And then what's the basic function on this one? Well, once again, the basic function, I can see I have a squared in here. So it's just x squared. And the x squared looks something like that to begin with. And then which kinds of transformations do you need to perform the basic in order to graph this? There's three things that are happening. Let's see. If I start with this here right there inside the parentheses, that's this one, that is going to be shift 1 to the right. And then if I go to this +2, I'm going to shift up 2. And then when you've got this negative out in front, that's the third, that's going to be, since it's a negative of the x squared, it's a negative on the whole thing, you are going to, it's going to flip upside down. Around the x-axis. So I know it's a frowny face, which means it can't be that one. That's a smiley face. And my original graph was at the origin, and then we shifted it. Remember the original graph, which was red. Let me go back up here. Okay, so I'm gonna take my, let's go in yellow. I'm going to take this point here and I'm going to shift it to the right 1 unit. Then I'm going to go up 1, 2, so that my graph looks like that, and then flip it upside down. And when it flips upside down, it's going to look like that. So my vertex is now in quadrant 1, and that's this one right here. This one's in quadrant number 2. That's not it. This one's in quadrant 4. That's not it. It's this one. It's C. And now I am done. Oh, go up here. Okay. Oh, I had 3 holdouts. You guys got any questions? Are you still there?
Yeah, we're still here. Just it's not hard. It's just there's a lot there, and yeah, it's not hard at all. But all right.
You got to think it through.
The only type of question I have, I can figure that out on the YouTube video. I just missed some notes, so.
Okay. I can go
Let's
back.
come back.
I can scroll it back if you need me to.
Nah, I'll be good.
You sure? Okay.
I'll just rewatch the video
Okay, cool.
and
All right.
re-listen to y'all.
Christian,
Thank you, though.
You're welcome. Christian, you got any questions? Christian. He's gone. Bye-bye.